overview. First of all, I'm going to talk a bit about the history of containers, how it became a thing. Then I'm going to talk about the software revolution, how we develop software has changed over the years. Then I'll take you for a journey through the wild west of app development and some of the tools and things you can use. And then we'll talk about container orchestrators and then a little overview at the end, and I'll give you some useful links. I do have a session in this room directly after this, so if you want to know more about Maven Central and some of the security aspects of it, do please stay around. So to get started, the history of containers. Essentially, before containers, what did we have? Well, we had local data centers. We used to use storage, like floppy disks, if you ever use those. That's the save icon. CD drives, CDs and stuff like that. We also used to use Cloud Foundry quite a lot for deployment, so some of you may have had a bit of experience there. Of course, bare metal and mainframes. So funny enough, my first job at IBM was actually on mainframes, which was quite a learning curve coming out of university where you're used to using nice GUIs, etc., to go onto a green screen of technology that's about 50 years old. So yeah, that's kind of my experience. So kind of how it all begun. In the beginning, this is 1979, we had the Unix v7. This kind of paved the way for containers. So this introduced the ch root system call, which is what we use for containers today. Then, if we fast forward a little bit, we then get to control groups. So this was something Google introduced, and essentially it made it a lot easier to basically split resources in your system into specific different areas. Then if we go forward, then we had Linux containers. Has anyone ever used Linux containers? No, so one person, nice. So Linux containers have been around longer than Docker, and a lot of people don't know that because Docker made containers very easy to use. But Linux containers was the first kind of full-blown framework, I would say, for building containers. So containers have been around a lot longer than Docker. But then, of course, Docker came along in 2013 and made our lives very easy. It made managing containers very easy. So that was great. And then later on, we kind of realized that when we have lots of containers, now they can start getting difficult to manage. So then Google created Kubernetes and gave it to the open source world, because open source is amazing. Okay, so what do containers provide? Well, they provide virtualization from an operating system level. They're nice and lightweight, fast startup. They're portable, which is the main point of containers. So you can take your image, you can give it to someone else in your department, and they should have the same experience that you had running on your machine. What do orchestrators provide? First of all, let me see. How many of you have had experience with containers or used containers? Hands up. So quite a lot of you. That's awesome. Okay. So yeah, containers are quite big now. But then again, now we need orchestrators because these things can start getting painful to manage. So what do orchestrators do? Well, they automate rollouts and rollbacks. They automate the scaling of your services. So when we got too much traffic, we can scale up and down. They can monitor the health. Yeah, lots and lots of things. And you can deploy anywhere. So when I say hybrid deployments, you could have running on your local machine. You could run in your local data center. You could run on the cloud. That's the point of containers, is you should be able to move your applications wherever you want them to go. So what do developers get out of containers? Well, we get isolated development environments. So if any of you have ever, all right, another question. Has anyone used test containers before here? Test containers? A few of you, okay. Test containers, if you don't know about it, I don't think I have much in this presentation, but check it out. What it does is it mimics your production environment on your local laptop, which means when you basically move from developing on your laptop into production, you shouldn't have any issues with moving because the environment should be exactly the same. So if you haven't checked out test containers, do check it out. It's open source, it's free, it's an amazing, amazing tool. But yeah, so what can we use? Portable, like I said, so we can develop on our local environment, and then we can send that to testing, that can go for our ops, and then go into production. We can pre-configure images, so like we do on Docker Hub, things like that. Generally, we have fast startup. It depends on the image. But there's no need to have prerequisites installed. So that's the good thing about containers, is we don't have to install a load of stuff to just do testing like databases, getting the right version of Maven, etc. We can just have that all pre-built. So the software revolution, how has things changed over the years? So microservices, when I started my career about 12 years ago, were quite a new thing. We mainly had monoliths before, although the concept of monolith wasn't actually created until microservices came around. But we generally had large runtimes, so I used to work for WebSphere. So WebSphere is a very big runtime. It's like, I think, 2 gigabytes. It used to take 2 minutes to start up, and as a developer, that's not acceptable. I need my applications to start up very quickly. So this was kind of the old way we used to do things, which was fine. I mean, WebSphere as an application server is amazing. It has everything in it, but for microservices and rapid development, it's probably not the best runtime to use. Of course, we had limited ability to scale, because when we had to scale the whole monolith, which was very resource hungry. And the problem is now we're all using the cloud. If anyone here has used AWS, you know you can rack up a very big bill very quickly. And that was one of the things that kind of pushed people to move to microservices, is to save money on the cloud. Just make sure I've got enough time, yeah. So this is kind of the different spectrums of architecture styles we have. The macro services is a debatable architecture style, but essentially we kind of had our monoliths. So a macro service, I will say, if you've heard of them, it's not a distributed monolith. A distributed monolith is what I would call a well-architected monolith. A macro service, you tend to find people getting to when they're trying to break apart a monolith and they realize some parts of it are so highly coupled, they just can't separate them all completely into microservices. So then we kind of end up in this state of a macro service, which essentially is when we get the highly coupled things and we put them into individual services. Now, this allows us to still scale and scale individual parts of our application. Now, it might not be as agile as microservices, but sometimes you just can't break a monolith apart into microservices without rewriting all the code. So that's where macroservices come in. Of course, microservices, we all probably know what they are, but then we get down to a function as a service. You may know this as a serverless. I don't like using the term serverless because there's always a server there, and I hate that term. But yes, so functions as a service is kind of the architecture we get to when we want to come up, do a job very quickly, and shut down. The thing you need to know when you're going into function as a service is you need to be able to scale down to 0 to save money on the cloud. So that is the differentiating factor, I would say, between microservices and function as a service, is you need to scale down to 0 with function as a service. So in order to do that, that means you need something, the ability to start up in less than a second. Otherwise, your users are going to have lag when they're trying to connect to your system. So explain a little bit. So all parts of the application are in kind of one deployment with monoliths. Like I said, it can have long startup times, but monoliths have very high throughput. One of the problems we find with Java and microservices is you have to have a JVM in every microservice. That is a big overhead to have in every microservice, whereas some programming languages, you don't have to do that. So bear in mind, Java is not always the best language to use for microservices. But like I said, monolithic architectures aren't always bad. You really need to pick what kind of architecture you want, because monolithic architectures have very, very high throughput generally. They're very robust. So when I worked in WebSphere, we went to the US to go and talk to one of our clients about turning their WebSphere application server into WebSphere Liberty or Open Liberty, which is the more modular one. And we looked at it and basically said, yeah, you should probably leave this as a monolith because the amount of time it's going to take you to do this is going to be very long. Plus, they had that server running for 20 years and had never restarted it. So at that point, we're sitting there going, yeah, I don't want to turn this off, to be honest, because, yeah, everything might break. Then we moved into the macro service architecture, which, like I said, it's basically where you get really high coupled services in a monolith that you can't break apart. It's able to scale, but not quite the efficiency as a function as a service or a microservice. They can be a lot easier to manage than microservices because obviously you don't have as many of them. And they're obviously a lot cheaper than the cost of a full rewrite to get your monolith to microservices. And runtimes for this would include stuff like Open Liberty, possibly JBoss, Wildfly, and things like Payara. So now we're in this new world, like I said, of architecture, and everyone keeps screaming at everyone, microservices, 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 microservices. Now, I would stress once again, microservices are not the best fit for every application. So do do your research on what you need to get out of them. But when you need stuff like you want really fast startup or a low memory footprint, this is where microservices come into play. Then we can move to something function as a service. So this is, you need really fast startup for this. Like I said, you want milliseconds, so 0.1 seconds. Like I mentioned, you need to be able to scale to 0. You don't want to be on the cloud with services there that are costing you money when you've got no one using them. So scaling up from 0 to 1 in 0.1 seconds helps you save a lot of money on the cloud. You want low memory footprint, but they can be very complicated to maintain. As you can see, we've got lots and lots of things here to maintain as opposed to just one. Now, you've all probably heard of Quarkus. Quarkus is great because you can compile to native, and that's got very fast startup time. OpenLiberty now has a new functionality. It's in beta at the moment, but what it allows you to do is essentially create a snapshot of when you started up and resume from that snapshot. It uses some of the functionality in the Linux kernel, but essentially it allows you to start up in, I think it was like 0.01 seconds, and that's with a full JVM, full runtime, Jakarta EE support, the latest microprofile support, all while using a full-blown JVM. So yeah, think of microservices like a kind of town. When a business is at capacity, you would generally expand that business or create a new one. Each business is part of a functioning town, so you'd have your bakers, you'd have somewhere to get milk, etc., things like that. And external services can be used, but they might be costly to set up in each town. So essentially, you would want to share a service between as many microservices as possible on the cloud to bring down the cost. Now, benefits of modernization. It's not just money that we can save here. The main things are avoiding downtime, of course, saving money when using the cloud, scale better. But the one thing I like to point out is this one, saving energy and sharing resources. Now, we all used to, traditionally companies would have their own data centers, we'd run those data centers, but the problem is they're very costly in terms of money, energy. Cloud providers put a lot of effort into saving energy. Their main cost, once they have set up their cloud, is energy, right? So here's some stats about energy in the world. There's over 500,000 data centers now in the world. You don't see them every day. They're hidden away in sheds, in big buildings. And there's about 6,000 big ones. So when I say 500, 500,000, that is the smaller ones we have in our companies, etc. But there is a lot around the world. Oh, sorry, yeah, that's the size of how much they consume. And if we put them, this is in 2019, so I imagine in 2023 this is a lot higher. But if we took the whole of the United Kingdom's energy supply, times it by 1.5, that is what data centers are using around the world. So that's 3.5 countries worth of energy that data centers are using. Now, because we have some amazing hardware engineers in the world, they have done a great job at saving us energy. So if it wasn't for the hardware advancements we have today, we would be on this track here. But luckily, because of all the amazing engineers making our hardware even more efficient, we've curved that and we're going that way now. But if there's anyone in the world that needs to do this, it's us. We are engineers. Engineers are the people who are going to save the world. So it's on our responsibility to make our applications as efficient as possible, not only to save our companies money. Yeah, that's great. We can save them a bit of money, but we can save energy by making our applications efficient. And there's lots of different programming languages in the world. This is a great list. You can find this online. But this basically did a bit of research to figure out the most efficient programming languages in the world. And Java is still nearly at the top, which is amazing. So just wanted to reiterate, as engineers, it's our responsibility to do what we can to make our applications efficient. Imagine if every microservice in the world started up 1 second quicker. How much every function as a service started 1 second quicker, used 10% less energy while running. Imagine how much energy that would save worldwide if we did that. So that's the kind of thing that I want everyone to think about. Rather than just saving our company's money, saving energy is also the reason behind a lot of this. And I like talking about this because, yeah, it's getting warm these days, guys. So a developer's journey. So we kind of go through a journey when we're designing stuff. We pick our architecture type. We will pick, what kind of specification we want to use, whether it's Java SE, Jakarta EE, Spring, etc. We have our IDE. Then we'll start thinking about what runtime, where we're going to put this. So are we going to use a traditional runtime? Are we going to use something like Lambda functions on Azure, things like that. Then we need to think about how we're going to build the application. Are we using Maven? Are we going to use Jenkins in here? Are we also going to use some automation tools? And then we kind of get to the level of, are we going to use containers? Is that a good idea to use? Should we use virtual machines? Do we, like I said, Lambda functions? And then we need to figure out how to do configuration of these things. Also, SBOMs. Has anyone heard of the SBOM before, that phrase? A few of you, okay. So SBOM stands for Software Bill of Materials, and I'll go through in a little bit why that's very important. But I'm running out of time here. Okay, 12 factors. Who's heard of the 12 factors? Anybody? Cool, guess what? There's 15 now. Of course, with software engineers, we like to add more stuff. Can anyone tell me what additional factors are here in the 15? Anybody? So we have API first, yep, and telemetry, like you all said, and authentication and authorization. Why was security not on the original 12 factors? What were they thinking when they built 12 factors and didn't even think about security? But yes, it's now 15, and authentication and security is an important one. Now, because I work for Sonatype, we do a lot of security products, so security is quite important, a thing I like to talk about. So open source application development. Open source, of course, is amazing. I think something like 80 to 90% of all the code in our applications now is borrowed code from online. Imagine all those dependencies you download from Maven Central. Imagine writing all that yourself. That's a lot of code. So it's amazing because we're all sharing code with each other. When you're using open source development, you've got a bigger pool of talent to pick from. Generally vendor neutral, so you can move stuff around. You're not locked into a specific vendor that might start charging you loads of money in 5 years' time. Less intentional bugs, and I've highlighted intentional there, and you'll see why in a moment. Generally simple to consume, so if you've got Maven, we can easily pull down these things. But security is a big problem with these things. So, like I said, 80%, I think it's more than 90% nowadays, but again, security is very, very important. And it's usually a thing that people think of last. So why is security important? Well, let's have a look at some crazy facts. So in 2016, cybercrime surpassed the drug trade. It was earning $450 billion a year. That's $14,000 a second. That is equivalent to 50 nuclear-powered Nimbus aircraft carriers that the United States build. Imagine that is what cybercrime was making in 2016. Do you think it's more in 2020, everybody? Guess what? It's increased a lot. So it's talking $6 trillion a year now. That is $200,000 a second. That is equivalent to 620 of the world's biggest aircraft carriers. That is what they're doing. And if cybercrime was a country, yes, I updated it, so India has surpassed the UK. If cybercrime was a country, it would be the third largest country by GDP in the world. So security is becoming a big thing. And if Pablo Escobar was alive today, he would probably get into hacking rather than the drug trade because there's a lot more money in it. So this is why I wanted to stress that this is important. And the reason why is because we're borrowing code nowadays. We're basically downloading code and not thinking too much about who's touched it, where it's gone. And unfortunately, hackers are getting very clever. They realize firewalls and networks are getting difficult to penetrate, so they're doing a lot of social things to try and get in. So for example, they might pretend to be a committer on a big open source project for, I don't know, a year. So you think they're, a valid part of the community, you think they're helping you. Guess what? They could be putting in vulnerabilities into the code which you trust and you love and you use every day, which then goes in production, and then you have a vulnerability that can take your business down. And if you work for a small to medium-sized company, it could be the end of your company finished. So do pay a lot of attention to security. But there's lots of tools to help you on this journey. Like I said, how you make your application, how you run your application, how you build it, etc. So I'll go through a few of the tools. Has anyone ever developed in a cloud IDE, something on the cloud? I know now GitHub has a thing where you can just press dot and it'll take you to an IDE, which is amazing. But this, in my opinion, will be the future eventually. There's no point of us wasting money and energy on building super-powered laptops when the cloud is available and we can do that. Now, there's also, you probably know, Docker's put some limits on it. It's also put some things on licensing. Podman has come to the rescue by Red Hat, which is open source and free to use. There's also, like I mentioned, you've got to consider runtimes. OpenLiberty, like I mentioned, has gone through a lot of changes to make it very cloud native. Like I said, the instant on stuff will start up in like 0.1 milliseconds, something crazy like that. So do check out OpenLiberty if you get the chance. OpenLiberty works with lots of different tools. That's the great thing about it. Oh, look, I updated the Maven logo. That's cool. So yeah, do check out OpenLiberty. Of course, you've probably all heard of Quarkus. Quarkus, like I mentioned, is really good for function as a service. It's got a unified configuration, and it's got Java native support as well. And there's some facts on how Quarkus starts up with REST and cloud native. So, okay, so now I'm going to talk a bit about DevOps, and this is the main thing I want to talk about. So I want to talk about build packs. Hands up here, anyone heard of build packs before? Ah, cool, a few of you, okay. So this is probably the session where I've seen most people know about build packs, which is awesome. So build packs kind of came from what Cloud Foundry used to do in terms of building. It was conceived by Heroku. They are the people that created 12 factors, and now 15, forgetting security. And kind of Pivotal and Heroku kind of joined forces to create build packs. So what do build packs offer? Advanced caching, auto detection. It will produce you, like I mentioned, a SBOM. It's modular and pluggable, and it works with loads of different languages. And like I mentioned, Java is not the ultimate language for every situation. I would say Java for function as a service and microservices is not the best. That's where build packs are really great, because I could use Python for one thing, Go for another, and Java for another, and it'll build it all for me. So yeah, it tries to create the minimal size app image. In terms of security, it will automatically update your underlying Docker image without you having to rebuild. So it updates it for you, which is amazing. It's really good for reproducibility, because I can just give someone the configuration for my build back and it'll build it on their laptop. So that's where Paquito comes in. So Paquito is like the tool and the technology for building these things. It transforms, essentially, you point it at your source code and out will come a Docker image. It's completely open source as well, and it supports the most popular languages, PHP, Java, blah, 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 blah. How much time I've got? I've got 5 minutes, okay. And it allows you to easily build your application, and like I mentioned, keep them updated. There is another technology, Red Hat source to image. This essentially is kind of similar. You point Red Hat source to image at your source code, and out will pop an image. It produces ready-to-run images, and it essentially injects your source code into the container image and letting the container prepare the source code for execution. So then we move on to Jib. Anyone heard of Jib? Jib? Yeah, a few of you, cool. Jib is quite simple, it's nice. It's implemented in Java and runs as part of your Maven or Gradle build. It's very, very fast and to take advantage of image layering and, again, being reproducible. You can find this online. I think this was on the Cloud Native Cloud Packs website, but it does go through some of the functionality that each tool offers you. Okay, so storing your containers, you've got lots of different options here. Of course, you've got a Docker registry. How many of you have used Nexus before? Heard of Nexus, used it? Awesome. So Sonatype, we produce Nexus. And this is kind of the backbone, really, of Maven Central. So if you stick around in 4 minutes' time, you will hear me talk a little bit about that. Of course, if you're using OpenShift, it may make sense to just use the OpenShift container registry. And of course, you've got cloud registries, so you could use whatever's on AWS, whatever's on Azure. Just bear in mind, you might have to pay for some of that. Like I mentioned earlier, I don't have time to go through this in much detail, but test containers are amazing. Do check out this technology. It makes moving your applications from development into production a lot easier without having the pains of, oh, Maven's at a different version, oh, this tool's at a different version. Test containers basically mimics your production environment locally on your developer's machine. I'm going to have to very quickly go through this because of the technical difficulties, but container orchestrators, you probably all know what I'm talking about. Microservices are great when we have 1 or 2 of them, but then when we get hundreds, it's very difficult to manage. And this is where container orchestrators come in to make it nice and easy. So it can do stuff, like I said, horizontal scaling, self-healing, all that good stuff. OpenShift, you probably all know what that is. So it's a Kubernetes-based platform with added functionality, and it kind of streamlines your DevOps process. A lot of Sonar-type technology and a lot of different technologies work with OpenShift as well, which is amazing. And OpenShift is hybrid as well, so you can deploy it. You can deploy it on your laptop. I wouldn't try and do that. Your laptop might set on fire, but you can deploy it in your local servers, virtual, or you can put it on the cloud or a private cloud. Rancher is quite a new thing that I've been playing around with. It's very, very cool. It's free to use as well, but it's essentially another container orchestrator to make your life easier. So in the essence of time, I'm going to wrap up. We all know containers are great. I hope we all know containers are great. There are tools for pretty much every application. There's new container tools coming out every day. The software stack is only as good as its weakest components, and we need to automate everything. And a little bit of homework. If you all go and have a look at your applications, take a look at the 15 factors and see if you are abiding by them all, and go and create an SBOM, and yeah, just have a look. So with that, some useful links to end off, and if you want to get in touch with us, here's the stuff here. But thank you for my talk, and yeah, hopefully I'll see you in the next one.